Hello everyone, what's up? Welcome to the class. Good evening everyone. और बताओ क्या हालचाल सब बढ़िया? Everything's going fine, I hope. So, my dear friends, welcome to Catalysis by Vedantu. If this is your first session, then awesome. My name is Pahul. I am an alumnus of IIT Bombay. You saw a little bit of idea about me in the slide that was up before I came here. So, welcome to this channel. Now, in the previous classes of this particular chapter, we've been doing this chapter for around 3 to 4 weeks now, 3 weeks, yeah. And we have discussed all the other things that are there in this chapter apart from the quantum mechanical model of the atom. So, be it photoelectric effect, be it black body radiation, be it quantum theory of light given by Planck, be it Bohr's model of the atom, etc, etc. So we've already discussed all of those things, and in the previous class, if you remember, that in the previous class I gave you a question, yeah. Let's open that question up. That was a homework question for the Hall of Fame. So in today's class, we'll first do the homework question. We'll do a little bit of practice for the next 10 to 15 minutes. And then we will begin with the ideas of the Schrodinger's wave equation. All right. So my dear friends, if I'm audible and visible, if you can see me and hear me, please write yo in the chat box. Let's get into it. Awesome. तो ये क्वेश्चन करते हैं आज, and I saw that a lot of people did silly mistakes in this question. So read the question and we'll solve it quickly. This was a homework question, all right. If a certain metal was irradiated by using two different light radiations of frequency x and 2x, the maximum kinetic energy of the ejected electrons are y and 3y respectively. The threshold frequency of the metal will be. So what does this say to us? This says that Hx, this is the case number 1, okay, let's say the first equation is Hx minus H nu naught is equal to y. Yes, and the second thing is, if 2x is put on to this metal, so H times 2x minus H nu naught, threshold frequency will remain the same for the metal, is equal to 3 times y. Now what you have to do is, you have to tell me what's the threshold frequency of the metal in terms of the unit x. What do we do over here? In these equations, let's just eliminate x. What I will do is, I will multiply the first equation by 3 and subtract the second one. Okay, if this is equation 1, equation 2, do this. 3 times 1, 3 times equation 1 minus equation number 2, do this. What will you get? 3hx, 3h nu, 3y, isko subtract kar do. Okay, all you need to do is just subtract these two. Once you subtract these two, sorry, मैंने यहाँ पे 3x लिख दिया, should have written 2x over here. ये Hall of Fame बाद में अपन बात करेंगे. I think these people might have made an error. ठीक है, तो एक सेकेंड. 2x minus 2h nu is equal to how much? Sorry, क्या कर रहा हूँ मैं? Wait. Fine. ठीक है, सो मैं इसको सब्सट्रैक्ट कर देता हूं. एज सून एज आई सब्सट्रैक्ट, यू विल रियलाइज दैट y इज कैंसल्ड आउट, है ना, राइट साइड पे 0 हो जाएगा. सो वील गेट द इक्वेशन इन टर्म्स ऑफ x एंड h nu. फाइन. सो अब कैसी इक्वेशन दिखेगी अपने को? इफ आई डू दिस, आई विल गेट 3hx minus 2hx. यस, फाइन. यहां पे क्या हो जाएगा? दिस विल टर्न इनटू अ प्लस साइन, दिस विल टर्न इनटू अ माइनस साइन. व्हेन यू ऐड देम अप, दिस विल बी 2h nu naught equal to 0. Yes, 3hx minus 2hx, ये कितना बच गया? This is just equal to hx. Now cancel hx, and once you rearrange this, this is equal to x by 2 is equal to nu naught. Very simple idea. Yes, बहुत simple सी बात है. All you needed to do over here was eliminate the y. So just multiply the first equation with 3, subtract the second equation from it, and the answer that you will get is x by 2. So my dear friends, all the people who did the answer correctly are given over here in the Hall of Fame. Yes. So congratulations to everyone who has their names over here. Give me a high five, write high five in the chat box if you had your name over here. And the text mentioned right next to their names is the songs that are favorite of these people. Akanksha and Ravi did not mention any songs. Next time please do so, otherwise you won't be featured in the Hall of Fame. Okay, awesome. चलो थोड़े और क्वेश्चन करें. Yes. A lot of people had done a mistake. Some people had written 2x by 3. ठीक है. And Archit, no, this is not recorded. This is a live session. Yeah. ठीक है. Don't worry. I have only one pair of eyes, so I can either look at the screen or look at the chat box. Can't look at both things at the same time. That just doesn't make sense. Yeah. Have to maintain the continuity of the class. So as I said, in the first 10 to 15 minutes of this episode, we'll do some questions and then we'll jump on to Schrodinger's wave equation. तो ये बताओ फटाफट से करते हैं ये question. We have 2 more questions. Let's do this. Which of the following are the correct graphical representations based on the photoelectric effect, assuming n is greater than n naught? Essentially, they mean to say that nu is greater than nu naught. Incident light frequency is more than the threshold frequency. ठीक है, तो फटाफट से ये देखते हैं. What does it say? Let's just write the photoelectric effect once again. So it says h nu minus h nu naught is equal to kinetic energy. That's what it says. Yeah. Let's look at the first option. First option says that by increasing the nu, by increasing the incident frequency, my kinetic energy will remain constant. Does not make sense, right? Kinetic energy will increase with the increasing nu. Increasing frequency will increase kinetic energy. This is wrong. Second statement says that kinetic energy will increase with increasing the frequency. But the graph is not starting from 0. The graph is starting after a certain point of time. Okay. But over here it was already mentioned, over here it was already mentioned that nu is greater than nu naught. So we don't need to worry about where the graph is starting from. कहाँ से start हो रहा भी फर्क नहीं पड़ता अपने को. This graph, even if you extrapolate over here, is correct. चलेगी बात. Third says that kinetic energy increases with the intensity of light. No, we have learnt in the quantum mechanical theory of Planck, quantum theory of light, that light can give energy to the electrons only one quantum at a time. Intensity is proportional to the number of quantum. Okay, E equals to nh nu जब बोलते हैं, this number is what refers to the intensity. Okay, and this frequency refers to the energy of one quantum. Now we know that one quantum can be absorbed only by one electron, so this does not make sense. This says that the number of photons will increase when the intensity of light increases. This is absolutely correct. That is what we are writing over here, yes. N is greater, intensity is greater, number of photons are greater. Fine. And if you have more number of photons, do you realize you can eject more electrons? Do you understand this idea? अगर इलेक्ट्रॉन ही ज़्यादा है शुरू में, my ejection will be higher. Sorry, if the photons are higher in the beginning itself, electron ejection will be higher. Every photon can attack one electron each. ठीक है? So the correct statements over here are 2 and 4. Fine. So this helps us understand the graphs behind photoelectric effect, and such questions are very common in JEE mains. Also in JEE Advanced, also in NEET. Because these questions don't require a lot of calculation, they can be done quick, perfect for objective type examinations. Let's do this question and then we'll move on to Schrodinger's wave equation. Photoelectron emission is observed for 3 metals A, B and C. The kinetic energy of the fastest photoelectrons versus frequency nu is plotted for each metal. Which of the following graph shows the phenomena correctly? There are 3 metals A, B and C. All of them will have different threshold frequency. Yes. All of them will have different threshold frequency, isn't it? है ना? So A का threshold frequency और मान लो is VA. B's threshold frequency, let's say nu B. C's threshold frequency is, let's say, nu C. I can say that, right? Fine. Now, my dear friends, it says that single frequency is put on all of them. So, do you realize that first it will start for first metal, then it will start from this for the second metal, then it will start for the third metal? है ना? For one specific metal, the graph will look like this. Okay, kinetic energy of the electron. Okay, so let's say this is nu A. Fine, this point that I've marked on my graph is nu A. So till nu A is reached, my effect will not be shown. But as soon as nu a is reached, then my kinetic energy will start increasing linearly with the incident frequency, है ना? Frequency जैसे बढ़ाऊंगा kinetic energy बढ़ती जाएगी, right? Now, my dear friends, if this point is your nu B, then for B, starting from the 0 point till nu B is reached, there won't be any photoelectric effect. Then photoelectric effect will start happening. Similarly, if nu C is here, for C the effect will start from here. So the photoelectric effect will start with different frequencies for these different metals. ठीक है? If it was the same metal, then it would have started from the same point and the slopes would have been same. So my dear friends, the only correct option over here is option number C. ठीक है? यहाँ पे B है, यहाँ C है. One more reminder to all of you that always read the question carefully. Sometimes they give A, B, C, D like this. Sometimes they give A, B, C, D like this. Okay? So please don't do that silly mistake ever again if you did it this time around. Fine people? Awesome. चलो आगे बढ़ते हैं. Now, Schrodinger's wave equation or the quantum mechanical model of the atom considers the wave nature of everything. Till now, what have we been doing? Till now, we have been explaining the models of the atom in terms of particles, yes. Initially, it was a plum pudding model. There's a positively charged sphere, negatively charged particles embedded in it. Yeah, and Rutherford's model was nucleus, electrons revolving around it like a particle. Then Bohr's model of the atom, nucleus, electrons revolving around it like a particle. So the word particle and particle nature was key to all of these models of the atom that we've done earlier. They were only talking about the particle nature of everything. But now we have understood, yes, अपने को अब चमकता है कि it's not just about particles, isn't it? Yeah, it's not just about particles. यहाँ पे तो अपन wave nature की भी बात कर सकते हैं. Yes. अपन wave nature की भी बात कर सकते हैं, isn't it? Because we learnt, according to de Broglie's hypothesis, lambda de Broglie can be written as h by p. Yes, लिख सकते हैं ना? So, my dear friends, the idea over here is that everything has a wave nature in it. And when science progressed, people thought ki yaar, instead of just talking about the particle nature of everything, why can't we take a model of the atom which has the wave nature of things in it? है ना जी? Why can't we do this, that we think about the wave nature of everything and define a new model of the atom which takes into account this wave nature? है ना जी? कर सकते हैं. Fine. So my dear friends, now let us familiarize ourselves with wave functions. Just to remind all of you, this is a class meant for 11th class students. In case you are here to revise the atomic structure, you are wasting your time. If you are studying atomic structure in 11th class for the first time, this class makes sense for you. Fine. Chalo. So let's familiarize ourselves with wave functions. My dear friends, can you tell me what comes to your mind when I say the word wave? अगर मैं wave बोलता हूं तो आपके दिमाग में क्या आता है ये बताओ मेरे को. ठीक है? I know the board is not visible. I have deliberately made the board invisible. Now it is visible. So बताओ मेरे को, what comes to your mind whenever I say the word wave? Vansh is saying, could you please explain the concept of Hall of Fame? Vansh, please attend our classes regularly. What we do is, we sometimes give homework questions and whoever answers those homework questions correctly, the fastest in the comment section of that video, gets featured in the next video. Yeah? Target Aims Delhi is asking, is this helpful for NEET 2022? Absolutely yes, it is. ठीक है? So, जब मैं waves बोलता हूँ, let me read your answers over here. Ashutosh is saying that sin x comes to my mind. And Biswaroop is saying that sea wave comes to my mind. वो दरिया में जो चलती हैं. Okay, interesting. And oceanic waves, disturbance, tides, crests and troughs, etc., etc., etc. Yeah, fine, makes sense. Yeah. Whenever I think about a wave, I think about something like this. Exactly, right? Sometimes you throw a stone into water and then you create waves, etc., etc. So all of us have similar ideas about what waves are, and whatever defines that wave mathematically is known as a wave function. One very simple wave function that we all know is the trigonometric wave function sin x. ये सबको पता है? It's a very simple wave function. Now what we'll do is I will switch to a very interesting website for all of you where we will try to play with this wave function. ठीक है? Sometimes maybe in math classes you've played with this website. हो सकता है आपने देखा हो. So my camera will be invisible for a little while. ये देखते हैं क्या चल रहा है. So let's plot sin x over here. Sin x plot कर दिया. As soon as I write the wave function sin x, I get this particular thing. है ना? ये मिल जाता है मेरे को sin x. Now my dear friends, I can also plot cos x. Different wave functions, looks different from each other. Fine. Now if I have to change the way sin x looks, इसकी मेरे को हुलिया बदलना है. I want to change the way this sin x is looking. I can put a number on top of sin x like 2 sin x. Do you see how the graph suddenly increased? Its amplitude suddenly increased. Yeah. This website is called Desmos. Pulkit sir uses it a lot in his classes. Maybe Neha ma'am also uses it in classes. Maths teachers use करते हैं इसको classes में generally. ठीक है? So it's Desmos. Yeah. Fine. 2 sin x. Now I can change the look of the graph in a different manner as well. Do you see the frequency of the graph has changed suddenly? The graph is oscillating a little more now. Yeah? Even more now. Just by putting sin 10x over there. Now if I do 5 sin 10x, it becomes a huge graph with a lot of amplitude and a lot of frequency, small wavelength. Yeah? Etc. etc. So when I'm playing around with this sine function, I can change its shape. Yes, I can change its shape. चलो, तो वापस आते हैं onto the whiteboard that we have. ठीक है, एक सेकेंड, इसकी full screen हटाने दो. Let's come here. Fine. If I have to write a general sine function, if I have to write a very generic sine function, I can write it as a sin bx. Is that right? क्या मैं ये लिख सकता हूँ? A sin bx tells me about a very generic wave function. Yes, बिल्कुल generic. A sin bx कुछ भी हो सकता है इसमें. I can change the numbers a and b to vary the wave function. Fine. अच्छा, ठीक है. Now, my dear friends, when we talk about wave functions in terms of particles, okay, when we talk of wave functions in terms of particles, wave function is like a user manual. Okay, whenever you buy a computer, whenever you buy a new motorcycle, whenever you buy any new tiny little gadget, it always comes with a user manual, isn't it? What does the user manual have? User manual has all the information that's necessary for you to understand the equipment. Yeah, it tells you how much battery you need, what should be the correct voltage of the battery if you're putting a DC supply, then what should be the voltage of the adapter that you have, what is the warranty period, etc., etc. So the user manual essentially contains all the information about that device. Yes. The wave functions that we have over here in terms of particles, these are like user manuals for our particles. Interesting, right? The thing is that we know already that particles can be talked about in terms of waves. As a particle, if I'm a particle, if I'm moving around, I'm a wave, and that wavelength is given by de Broglie's hypothesis. Now, moving one step further, I can define a wave function for myself. It's going to be very complicated. No scientist ever is going to be able to solve that, because as humans, we are complex creatures. But if you have any particle that's under motion, you can give a wave function to it. That wave function will contain the entire information about that particle. Okay? So, if I have a wave function of my own, if I give that wave function to you, you'll know exactly what I do in a day, what are my likes, what are my dislikes, etc., etc. That will be like a user manual about me. Okay. So you also would have a particular wave function. Nobody knows what it is because it's too complicated, because humans are super complicated, etc., etc. Yeah. So instead of talking about in terms of velocity kitni hai, how much is the velocity, what is the position, what is the distance, what is the energy, etc., etc., we will just give a wave function. For example, sine x over here, a sine bx. This has all the details about the sine wave function, isn't it? It tells me about the amplitude of the sine function. It tells me about the wavelength and frequency of the sine function. It tells me how much it repeats, etc., etc. So since every particle has a wave, every particle is a wave, every particle also has a wave function, and that wave function contains the entire information that there is for a particle. Do you now understand the idea behind a wave function? Yes. If you do that now, if you understand the idea of the wave function now, imagine if you were in the early 1900s, you would say that all the older people, all the Buddhas are giving old models of the atom where they're thinking of particle nature. I'll do something different. I will think about the wave nature of the atom. I will consider all the electrons as waves. The electron no longer is a particle moving around the nucleus, it is a wave existing in space. As soon as you do that, a lot of opportunities open up. You can now define the electron in terms of a wave rather than thinking about it as a particle, and that's exactly what this guy Erwin Schrodinger did. He gave the notorious Schrodinger's wave equation. What this does is that this considers electrons as waves. Okay? The Schrodinger's wave equation considers electrons as waves. So, my dear friends, now tell me, where will all the information about the electron be? Electron के बारे में जितनी भी information है, okay? Electron के बारे में जितनी भी information है, वो कहाँ पे होगी? वो कहाँ पे होगी? That information is going to be inside the wave function of the electron. Information about the electron contained in the electron's wave function. Very simple. And someone over here was asking a doubt that, sir, but the information can change all the time, right? That's absolutely correct. But talking about electrons, they are much more predictable than humans. So the wave functions of the electrons, even though they are very complicated, for simpler atoms like hydrogen, we can still try to solve what a wave function is. Okay? I'm pretty sure you realize that when scientists discovered the idea of wave functions, they would now want to find out what the wave function for the electron is, yes? So I'll tell you over here that for simpler systems like hydrogen atom, it's very easy to find out what the wave function looks like in case you know a decent amount of calculus, that is. If you don't know calculus, then it's a different thing altogether. But अगर integration differentiation आता है, तो एक level तक, after putting a certain amount of effort, you can deduce what is the electronic wave function for a hydrogen atom in certain conditions. That is doable. So for electron systems which have more than two electrons, more than one electron, like helium, lithium, beryllium, so on and so forth, even scientists are not able to solve the wave equations for those electrons, and we solve the wave function only for hydrogen atom, and then we use that information and say that every other atom is following the same pattern. ठीक है, मैं हिंदी में भी बोल देता हूँ, हम सॉल्व कर सकते हैं सिर्फ हाइड्रोजन एटम के लिए ज़्यादा से ज़्यादा, उसके ऊपर जितने भी एटम है ना, सबके लिए हम बोल देते हैं हाइड्रोजन जैसा ही कुछ हो रहा होगा यार. That is what happens when we solve the electronic wave function, right? And in case you go to college, first year में सबको chemistry का course लगेगा एक, every one of you will have a chemistry course in your first year, and then you will get to solve the Schrodinger wave equation entirely. Fine. So over here, what's happening? Consider the electrons as waves. Now the information about the electron is contained in the electron's wave function. So if we know ideas about the wave function, I can talk about electrons. If I know the ideas of the wave function, I can still talk about the electrons, yes. I can predict, okay, this is perhaps where they are moving. This is perhaps where they exist right now, etc., etc. Yes, isn't it? So this electronic wave function and finding out what numbers are associated with it, like this A and B, will tell me ideas about the electron. Fine. This electronic wave function is known as psi. Okay, this is a Greek letter PSI. If you've watched Pokemon, you would know that there's a Pokemon known as Psyduck. Okay, it's not Psyduck because the P is always silent. So psi is known as the electronic wave function, and instead of writing it as something huge, we concisely write it as just psi. So this is the first new piece of information for you guys, that the electronic wave functions, which contain all the information about the electrons, are known as psi. अपन उसको psi की तरह लिखते हैं. ठीक है? Fine. Awesome. Okay. Now let me try to show you what it looks like when we try to solve the psi. ठीक है? एक बार मैं दिखाने की कोशिश करता हूँ. Let me try to show you what it looks like. Are you ready? Let's see. So first idea is time independent Schrodinger's equation. Time independent बोले तो I'll tell you the meaning of the word time independent. Time independent implies that your system, okay, this is in line with the doubt that was asked in the chat box, the system does not change with time. Okay. What you are assuming is that the system and its characteristics don't change with time, which means that you do not need to think about time in the wave function and its solution. So what's given over here is h psi equals to E psi. Okay, this thing when simplified is written as h psi is equal to E psi. And let me try to explain what these terms are. See, psi is a wave function, isn't it? ये तो wave function है अपना, wave function, okay, great. This h over here, with this tiny danda on top of it, is known as the Hamiltonian operator. And right now you guys must be wondering, sir, what is this, what is that? Don't worry. With time, I'll try to explain as much as it's necessary for us. Okay? So, this is known as the Hamiltonian operator. I'll tell you an example of an operator and you'll understand this equation very well after I do that. This E is the energy of the system. What does this mean? देखो, बड़ी सिंपल सी बात समझाता हूँ. Okay, बड़ी सिंपल सी बात समझाता हूँ मैं. Again, taking the example of the user manual. Okay, user manual. Let's say you are playing with your video game, or let's talk about a mobile phone because everyone is acquainted with a mobile phone. Let's say you are playing with the mobile phone and assume you are not able to understand how to change the theme of your mobile phone. Yeah, you know, display में जाके themes वगैरह change होती हैं. Or let's say you are not able to put a new ringtone to this on the smartphone. Let's just assume. Of course, everyone can do that, but still. Now, what you need to do is you need to find out information on how to change the ringtone. Yes, you need information on how to change the ringtone. So what I need is, I need information on how to change ringtone. Yeah. What will we usually do? We'll just go to Google and type this is model of the phone, how to change ringtone, etc., etc. But assuming that internet is not in the picture over here, what will you do? You will do something to the user manual so that you can find the information out of it. Yes. You will manipulate the user manual in a manner. What will you do? Simple se baat bolte hain. You will open page number 25 of the user manual, let's say. So, what I need to do is open page 25 of user manual. Once I do this, I will get the information of how to change the ringtone from the user manual. My dear friends, can I call this an operator? What I'm doing with the user manual is it contains all the information, but I need to know what to do. So what I need to do is I need to operate the user manual in this manner that I need to open page number 25. So I have done something to the user manual and then the user manual gives me this information. Notice the wave function now. I did something to the user manual and then the user manual gives me the information about energy of the system. Let me give you a very simplistic mathematical example over here. d by dx of e to the power x, or let's say e to the power 2x, is equal to how much? अगर सिंपल करना है तो सिर्फ e to the power x ले लो, इससे भी काम चल जाएगा. This is equal to e to the power x. Can I write it as 1 times e to the power x? What is this d by dx over here? This d by dx, I can call it the differential operator. What I am doing is, I am doing an operation on the wave function. This e to the power x over here can be considered to be my wave function. किसी का होगा wave function, क्या फर्क पड़ता है? It's a graph which we can plot. So once you do a certain operation on the wave function, it gives you a certain information. So this is like the energy of the system. Do you realize the similarity over here? I am not saying that e to the power x is a wave function of the electron, okay? But imagine that if there is a wave function which is e to the power x, this is what it will look like, yeah? If you put the differential operator on e to the power x, it will give you 1 times e to the power x. Does this mean that h is equal to E? Definitely not, because E is a physical quantity, h is an operator. When you operate psi with h, it will give you energy and psi. Okay. One more thing that you can look for, okay, this value of energy that we obtained. There are different operations that we do on psi to get different information. We can get velocity, etc., etc. Again, these are all theoretical concepts. Ideally, working with them is really difficult. But after the class, this is like a self-study assignment. Okay, after the class, try to search for this term. Okay, ये term search करना, eigenvalue. Okay, try to search for this term. Just do a Google search on it. Just read a Wikipedia article on it. ठीक है, eigenvalue नाम की चीज को search करके देखना. Just try to search for this thing called eigenvalue, and you'll understand a lot of new things about how wave functions work. So the first form over here is given as time independent Schrodinger equation where there is no component of time, and when we elaborate this jazz, okay, for a single non-relativistic particle, essentially an electron, free electron, okay, this is what happens when you talk about a free electron, that it's not being influenced by anything else right now. So time independent Schrodinger equation for a free electron will look something like this. Okay, and this is the form that your Hamiltonian operator is taking. Minus h square by 2 nu del square plus Vr into psi r is equal to E psi r. What are these things? Abhi ke liye don't worry about it. Okay, what are these mathematical operators? Don't worry about it, because if we need to understand exactly what these mathematical operators are, we need to do a 6-month long course on mathematics as well, which is not necessary for now. This is what it looks like. You don't even need to remember these ideas. Moving on to a time dependent equation. So over here, psi will depend on r and t. What is r? R is essentially the coordinate system. If I have to tell information about you to someone else, let's say Raji is asking me where is Archit. Yeah, let's say Raji is asking me where is Archit. I will tell that Archit is from the origin, let's say origin is a tree somewhere, from the origin he is at x equal to 2, y equals to 5, z equal to 10, and you will find him there at time equals to 5 p.m. All the information about that person is over here now. Do you understand? R is the coordinate system which tells you the position of this particular substance, particular particle in question, and T tells you when it will be there. Something like that. So this is the form that your Schrodinger equation takes when you're talking about a time dependent system. Once again, no need to think about it. Okay. One piece of information for you guys. Okay. Today's class is about the basics of Schrodinger wave equation. Fine. These basics will help, or I should say these basics are more than enough for JEE mains and for 90% of JEE advanced and for entire NEET syllabus. ठीक है, वो स्क्रीन से बाहर चला गया, मैं नीचे लिख देता हूँ इसको. Fine. Today's class is about the basics of Schrodinger's wave equation, and these basics that I'm going to teach you are more than enough for JEE main syllabus, more than enough for 90% of the JEE advanced syllabus, and more than enough for the entire NEET syllabus. But the final class of this series, the structure of atom series, which we call the what's in the atom series, in the final class we will do some advanced level calculus on Schrodinger's wave equation. Okay, I think you have an idea of what I'm talking about. If you don't have an idea, don't worry, we'll get there eventually. But if you do have an idea, I'm talking about those places where you talk about the Schrodinger's wave equation in terms of r, theta and phi. Yeah. Have you seen those examples or questions where they teach you about r, theta and phi, and you know its implication in questions, etc., etc. So in the previous year JEE advanced questions, 2 or 3 times questions have been asked on psi depending on r, theta and phi. In JEE mains no one asks about it. In NEET definitely no one asks about it because it is not given in the NCERT. This is a very advanced level concept, and you don't even need to know the concept to solve those advanced level questions. It is just good to know. So we will do a final class on this series, which is going to be the first class of next week on the advanced level concepts. Today we'll deal with the basics. Fine. Basics are more than enough for JEE mains, entire NEET syllabus, and 90% of JEE advanced syllabus as well. The advanced concepts are a little more calculus dependent, and once you do more calculus in mathematics, you'll be able to do those questions as well by default, but we'll do a separate class on that as well. Fine. ठीक है. So all of your क्या कहते हैं curiosities will be answered as much as we can. It'll just take some time. Let's move on now. So right now what we will do is we will consider the mathematical conclusions as facts. This is something that is a little sad as a scientist. This is something that is very happy for us. It's a happy news for us as a student because we don't need to study a lot. So for now, we will consider the mathematical conclusions as facts, and we will go on a more qualitative journey to study the quantum mechanical model of the atom. अपन ना गप्पे मारेंगे इसके बारे में. We'll talk about the atom in terms of qualitative ideas. ठीक है कि electron might be here, electron might be there, this, that. Okay. We won't really go into the mathematics. We won't give the exact wave function. We won't do all the derivation, integration, etc., etc. So अभी बात सिंपल है, अपने को मैथमेटिकल आइडियाज को फैक्ट्स की तरह कंसिडर करते आगे बढ़ना है. फाइन. सो माय डियर फ्रेंड्स, we will now think about the atom in terms of wave functions. We have already done that. We have psi. Look at the second statement that I have written over here. This is very important, and a lot of people miss a mark on this. A lot of people do not understand what's going on as soon as we move forward. This statement is absolutely necessary to understand what is going on. See, these wave functions are characterized by quantum numbers. आ गया quantum number, something that is really important for our examinations, yes? Let me try to explain what quantum numbers are. Do you remember A sin bx? We talked about it 5-6 years back. Yeah? When I was teaching you about the sine function 5-6 years back, we talked about A sin bx. Yeah? And I realized that when I change A and B, I am able to change the wave function. So 2 sine 3x is one wave function, 3 sine 9x is another wave function, something sine something x is another wave function. Yeah? Do you agree with me that all the electrons will have similar wave functions? Because they're all electrons at the end of the day, right? Their wave functions will look slightly different from each other, that's all. थोड़ा थोड़ा अलग दिखेंगे एक दूसरे से. Isn't it? Yes. All the smartphone user manuals will be almost the same as each other. Page number 1, how to start up your phone. Page number 2, key components of the phone. Page number 3, how to open the application drawer. Page number 4, how to do settings, etc. It's just that the model of the phone will differ and some instructions will differ, but overall the wave function will look similar. Yeah. So now imagine that all the electronic wave functions look like sin x. How will they differ from each other? They will differ from each other in terms of these numbers. मैं हिंदी में भी एक्सप्लेन कर देता हूँ कि सब इलेक्ट्रॉन्स के वेव फंक्शन एक जैसे ही दिखेंगे. अब उनमें फर्क क्या रहेगा? What will be the difference between each of these wave functions? उनमें फर्क यही रहेगा कि उनके जो ये नंबर है ना, उनके वेव फंक्शन में जो ये नंबर लगे हुए हैं, ये नंबर अलग अलग होंगे. वो नंबर कहाँ लगे हैं, कैसे लगे हैं, क्यों लगे हैं, अपने को सोचने की जरूरत नहीं है. Where are these numbers in the wave function? How are these numbers written, etc., etc. We don't need to worry about them, but we need to understand that when I change these numbers for the electronic wave function, I will get wave functions for different electrons. Yes, fine, awesome. इतना तो सबको समझ आता है. Yeah. So, like you have A and B for sin x, similarly you have these numbers for the electronic wave function. ठीक है? So sin x के लिए क्या आया? A and B. Fine. There are certain numbers for the electronic wave function psi. Okay. What are these numbers? These numbers are written as. अब नई information share हो रही है आपके साथ. I'm going to share new information with you. These numbers are written as N, L, M and S. These numbers are written as N, L, M and S. These numbers N, L, M and S are known as quantum numbers. Fine. Similar to A and B for A sin bx. Psi is a little more complicated. It's a long wave function. We don't really know much about it. Neither do we need to. All we need to know is there are these quantum numbers N, L, M and S that characterize the wave function. Changing N, L, M and S will give you different wave functions referring to different electrons. Okay. So a certain set of these quantum numbers will give you a certain wave function, will point to a certain electron. Then a certain set of quantum numbers defines an atomic orbital. अब ये क्या है भैया? What is this atomic orbital now? Let me try to explain. Orbital, talking in terms of mathematics, is a region with very high, almost let's say 95%, okay, probability of finding the electron. ठीक है? Orbital is a region. It's a volume region in space where there is a very high probability of finding the electron. Let me give you an example once again. Let us say I have Priyanshu in the chat box and I have Erwin in the chat box. Yes, Erwin and Priyanshu are here. So, let's say Erwin asks me, where is Priyanshu? And I tell Erwin, Priyanshu is most likely at home. Can I say Priyanshu is definitely at home? Not really. Okay, in the lockdown things are different, but think about normal usual life. Aaron को मैं statement दूंगा that Priyanshu is most likely at his house. Why am I talking about most likely? Because I am not 100% sure. I'll say most probably at his house. Yeah. And that's a correct statement. More often than not, you would be found at your home, right? Unless you are out for some work or perhaps for buying some grocery, etc., etc. But again, I can never be 100% certain. Does this remind you of the example that I gave in Heisenberg's uncertainty principle? Heisenberg's uncertainty principle says that you cannot determine the position and momentum of anything simultaneously. For huge species like us, for huge macroscopic objects, the uncertainty doesn't matter. But for electrons, it does. So for the electrons, I cannot say this is where the electron is. Bohr's model of the atom hence is incorrect. According to Heisenberg's uncertainty principle, Bohr's model of the atom is incorrect. So what I can say now is that electron might be here. You ask me, sir, where is the electron? It might be here. यहाँ कहीं तो है. Where exactly? I don't know. It's probably somewhere in this region. That region with a very high probability of finding the electron is the orbital. So orbital is like the house of an electron. The orbital is like the house of an electron, and as I told you over here, a certain set of quantum numbers defines the atomic orbital. I can say that the quantum numbers are like the address of this house. Yeah, your house has an address, country this, city this, colony this, so on and so forth. Yeah, country, city, colony, house number. Let's simplify it into these four things: country, city, colony, house number. Similarly, for orbitals, we have NLMS. As simple as that. So what are these quantum numbers? These come out of the wave function, as I just told you, and what they do is they point you to the house of the electron. Electron tu kahan hai? Most probably yahan hai. It can be anywhere. Theoretically speaking, according to the quantum mechanical model of the atom, theoretically, not practically, theoretically, if there is a water molecule in the Pacific Ocean, there is a probability of finding its electron here. The probability might be 0.000000001%. But even then, if that hydrogen atom is somewhere near the United States of America, the probability of finding its electron exists here as well. Very tiny probability, which practically is zero. Yeah, but theoretically it exists. So orbital is the region which has a very high probability of finding the electron. We cannot talk about 100% probability because Heisenberg's uncertainty principle is now a reality for us. We will have to violate the Heisenberg's uncertainty principle. If you are able to do so and successfully explain that by an experiment, you will definitely win a Nobel Prize. Later on in life, if you are able to disprove the Heisenberg's uncertainty principle with a proper experiment, you will win a Nobel Prize for sure. Okay, ठीक है. So quantum numbers are like these, like the address of this house. ठीक है. So now in the next 5 to 10 minutes, I'll talk about the different details of these quantum numbers. Let's learn more about these quantum numbers, and I'll leave you with a tiny exercise. Okay, are you ready to gather some speed now? Till now the class has been a little slow because there was not lots of new information that I gave to you. If I straight away came to quantum number J hota hai, then you would have died. Okay, so now I'll tell you about what these quantum numbers are called, what are they referring to, etc., etc. Okay. So first we have n. N is known as the principal quantum number. N is known as the principal quantum number. Okay. L is known as the, ये सब लिखते रहो साथ साथ में, please write these things down. L is known as the azimuthal quantum number. Azimuthal quantum number. M is known as the magnetic quantum number. Fine. And S, right at the end, this guy is known as the spin quantum number. Fine. Okay. These are the names to these. So, like for a house, we have country, city, colony, something, something. Similar to that, over here we have principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Yeah. Country is the biggest. Country is the biggest set over here that we have. Principal quantum number is the biggest set that we have. Country के नीचे क्या आता है? Below country we have city. Similarly over here, below the principal quantum number we have azimuthal quantum number, then magnetic quantum number, then spin quantum number. So these are in terms of their hierarchies. My dear friends, I have a question for you. Do you understand that this model of the atom is purely mathematical in nature? Mehboob is saying, sir, if we are measuring the probability of the electron, does this mean the velocity is totally uncertain? Absolutely correct, Mehboob. Absolutely correct. The information about the electron is absolutely uncertain. We do not know what velocity an electron has. Okay. Fine. Shikha is asking about the idea of angular momentum. We'll talk about orbital angular momentum in the next and next to next classes. Okay, so later on in this week, the classes of this chapter happen at Monday, Wednesday, and Friday. Tuesday, Thursday, and Saturday at 7 p.m. As Tuesday hai. So next class will happen on Thursday, then on Saturday, 7 p.m. So we'll talk about the ideas that you're asking in those upcoming classes. Okay? Fine. So this model of the atom, as I asked you and had a little chat with you guys, that it's an entirely mathematical model of the atom. What we can do in order to make ourselves easier to remember this atom is to involve and associate it with an imagination. It is entirely mathematical, but just to understand it, we can think about some imagination. हिंदी में भी बोल देता हूँ, पूरा मैथमेटिकल मॉडल है, बट हम इमेजिन तो कर सकते हैं ना. वी कैन इमेजिन समथिंग ताकि हमारे लिए याद रखना आसान हो जाए. ठीक है. सो द इमेजिनेशंस दैट यू कैन एसोसिएट विद दीज नंबर्स आर ऑफ अ शेल, देन ऑफ अ सब शेल, एंड देन आई विल टेल यू अबाउट मैग्नेटिक एंड स्पिन इन सम टाइम. अभी के लिए शेल और सब शेल सोच लो, लाइक कंट्री एंड सिटी. Okay, so you can think about a huge sphere, and in that sphere there are certain regions, so on and so forth. We'll keep on developing this imagination as well as we move on, because the imagination is important for humans to understand and remember these ideas. Fine. Now let us talk about the rules of the quantum numbers. Yeah. If I tell you how many countries are there on Earth, you will give me a number like 196 or 197. There are some disputed countries as well. Yeah. Can you make up a country on your own? No, you can't say that this is new country. I call this country hula lala. There are certain rules to what those countries are named and how many countries there are. So similarly, there are rules to the principal quantum number, and the principal quantum number can take any natural number value. Which means that the principal quantum number can range from 1 to 2, it could be 3, it could be 4, so on and so forth, till infinity. This has to be a natural number. Fine. Awesome. Now that you are in a country, can I say that Pennsylvania is in India? Doesn't make sense, right? Yeah. Can I say Karachi is in Amritsar? Even more absurd statement. I can say Amritsar is in Punjab. I can say Punjab is in India. That makes a lot more sense, right? Yeah. That makes a lot more sense. So similarly, now the subshell has to be defined with respect to the principal quantum number. So subshell can take values from 0 to n minus 1. Okay, these are the values it can take. So let's say there is a principal quantum number 3, subshell can take values of 0, 1 and 2. We'll talk about what these numbers mean. अभी के लिए सिर्फ लिख लो ये number क्या है. Magnetic quantum number once again will depend on the subshell, and that can take values from minus L to plus L. So let us say you have the subshell value or the L value equals to 1. Okay, so M values possible over there would be minus 1, 0 and 1. ठीक है, we'll do more examples धीरे धीरे. अभी के लिए please write down the rules of these quantum numbers. Fine. And the spin quantum number can take only two values. It will be either plus half or it will be minus half. These are the rules behind all of these quantum numbers. Please write it down. In case you need more time to write it down, just pause the video over here and write it down in your notebooks. Okay, ठीक है. Cool. And a lot of you people must be thinking that, sir, it looks like a tough model of the atom. We're not able to understand everything. I agree. It is a tough model of the atom and you will not be able to understand everything in the very first class. The unfortunate thing about being human is that it takes time for us to speak. It takes time for us to explain things, and it takes time for you guys to understand it as well. Yeah. If humans were able to understand everything at once, then movies wouldn't be 2 hours long. Movies would be like they throw a piece of information at you and you know the entire movie. Have you seen Matrix? Have you seen the movie Matrix? What they do is they simply put a plug inside the head of the human and upload an entire module over there. So if that person doesn't know martial arts, plug karo, usme martial arts ka software dalo, that person now knows martial arts. Unfortunately, that can't be done with humans. Yeah. We can't install programs into us in seconds. So it takes time for us to explain things, and it takes time for us to understand things as well. So what I've explained today is just like, if the entire theory is this big, I've explained only this much today. I've explained only, let's say, 1/4 of what's going to happen in the quantum mechanical model of the atom. So sooner or later, eventually, slowly and steadily, I will explain all the ideas that are there. So now, my dear friends, what you have to do as an exercise after today's class, this is something that you have to play with apart from searching for eigen values. ये खेलना है आपको, ठीक है? ये खेल करोगे please. This is like a fun assignment for you. Take any number of shell. Okay, take any number of shell. तो shell कौन सा लिख सकते हो आप? Let's say 4. So for the 4th shell, how many subshells can be there? 0, 1, 2 and 3. Now for the 0th shell, what will be the M value? 0. For the first subshell, what will be the M value? -1, 0, 1. For the second subshell, what will be the values? -2, -1, 0, 1, 2, so on and so forth. Yeah. And for each of these magnetic quantum numbers, you will have plus half and minus half. तो spin तक जाने की जरूरत नहीं है. But can you do this exercise? Like take any random quantum number, natural number, let's say 6. For that 6 natural number, write all the subshells that are possible, and for all the subshells, write all the magnetic quantum numbers that are possible. Just try to do this exercise after the class. In the next class that is going to happen on Thursday at 7 p.m, we will begin from this exercise. We'll do this exercise first. Then we will give some names to these different numbers. We'll adhere these numbers to some rules, and then we will come to the idea of electronic configuration. ठीक है? So आज की class के बाद make sure you read the NCERT. ठीक है? There are 3 pieces of homework for you. First is to search for the eigen value. Second is to play with the quantum numbers, the arrangements of these quantum numbers, and 3 is to read the NCERT as much as you can. The second chapter of NCERT 11th class. Just read it as much as you can, the quantum mechanical model of the atom part. And on Thursday, we will build upon this. Thursday and Friday, we'll try to cover all the ideas that are there in the NCERT. And then we will keep one bonus class so that we can understand the advanced level ideas for the Schrodinger's wave equation. Fine. So that's the plan. Once again, I had lots of ideas to tell you guys today. Okay? And Priyanshu, my dear friend, please join the class from the beginning. Okay? शुरुआत से join करो तब समझ आएगा. As I told you that all the information can't be given to you in 1 second. So please be a little patient about it. Fine. धीरे धीरे समझ आएगा. Okay? Cool. So if you have any doubts that are relevant to this chapter, you can leave them in the comment section down below. We will get back to you if those doubts are reasonable enough. ये मत पूछ लेना मेलोडी इतनी चॉकलेटी क्यों है. Those doubts will not be answered. Cool. So people, thank you so much for joining in. I will take your leave. Now I have to take another live session for the revision of solutions chapter for 12th class students. So yeah, I'm going to see you guys once again on Thursday and we will continue the analysis of the quantum mechanical model of the atom. ठीक है? चलो, that's it. Bye bye. Take care.